Okay, let's do some maths. Now previously we'd looked at deriving the double angle formulas, and we used the addition of angle formulae, okay, and we got these for sine 2a, and we got 3 of them for cos 2a. We also did the same thing, deriving double angle formulas using cis, okay. Let's be daring now, and let's do triple angles with cis. Now, what we're going to do is basically follow the same idea as we have here. So we'll begin with cos 3 theta plus I sine 3 theta, which of course we can abbreviate that as cis 3 theta, okay, which also happens to be, using de Moivre's theorem in reverse, cis theta cubed. And this is cis theta times cis theta times cis theta. Now, with the double angle formulas, if you have a look here, cis theta squared, we've actually already done this. In the double angles with cis. So let's not do it again, okay? We'll just take the result that we got from that. So we'll write that down here as cis theta squared, which is cos squared theta minus sine squared theta, there's the real part, plus the imaginary part, I times 2 sine theta cos theta. And we're going to multiply that in here by cis theta, which will expand that out to cos theta plus I sine theta. Right. Now what we'll do is we'll actually expand this out here, and we'll keep the real parts together and the imaginary parts together. So we'll end up with this. So we'll get cos squared theta minus sine squared theta times cos theta minus, because we have I squared, 2 sine squared theta cos theta. Now I better use a new line here, plus I times 2. Now sine theta cos theta times cos theta will give us 2 cos squared theta sine theta plus, we'll multiply these two here, which will give us cos squared theta minus sine squared theta times sine theta. Close the brackets. Rightio. Let's expand these out here in the real and imaginary parts. See if we can look for some patterns and tidy them up. So we'll end up with cos squared cos, so cos cubed theta minus cos theta sine squared theta. Okay, I'm keeping the cos on the left hand side so that we may see some patterns. And then minus 2 cos theta sine squared theta. Okay, and the imaginary part now, plus I times, now 2 cos squared theta sine theta, didn't do anything there, plus cos squared theta sine theta minus sine cubed theta. Okay, now have a look at these two terms here. So we can rewrite this just a little bit more simply as cos cubed theta, cos theta sine squared minus 2 lots of cos theta sine squared. Okay, so minus that, minus 2 lots of the same thing, gives us minus 3 cos theta sine squared theta plus I times, now have a look at these two terms, the cos squared sine theta. So we've actually got 2 lots and 1 lot of that, so we've got 3 cos squared theta sine theta, finally minus sine cubed theta. Now we're pretty well done here. Let's just go back to the double angles using cis. We equated the real and imaginary parts and got 2 lovely equations. Let's do the same. So we will equate real and imaginary parts. So for the real part, what have we got? We've got cos 3 theta equals cos cubed theta minus 3 cos theta sine squared theta. Great. And the imaginary parts, let's equate them. So we're going to have sine 3 theta equals, what do we get? 3 cos squared theta sine theta minus sine cubed theta. Great, 2 really lovely equations. But let's go a little bit further. Let's rewrite cos 3 theta in terms of cos only. So what we can do here is use our Pythagorean identity, and we'll substitute in sine squared theta, and we can turn that into 1 minus cos squared theta. So let's have a look. We'll begin with this in here, and we'll sub in sine squared theta equals 1 minus cos squared theta. So what do we end up with? We end up with, so cos 3 theta equals cos cubed theta minus 3 cos theta, and then 1 take cos squared theta. Okay, let's just expand this out and tidy it up a bit and see what we end up with. Equals cos cubed theta minus 3 cos theta plus 3 cos cubed theta. Now have a look at these two terms. We can put them together, so we actually end up with 4 lots of cos cubed theta minus 3 lots of cos theta. What a lovely equation. Right, now let's have a look at the imaginary part. Let's do the same thing in there. Let's remove this offensive cos squared theta, and we'll use the Pythagorean identity again. So I'll just rewrite that. So sine 3 theta equals 3 cos squared theta sine theta minus sine cubed theta. Okay, so let's sub in cos squared theta equals 1 minus sine squared theta. So what are we going to end up with here? So sine 3 theta equals 3 cos squared, so 1 minus sine squared theta times sine theta minus sine cubed theta. Okay, let's expand this out, see if we can tidy it up a bit. Yes, we will. 3 times 1 times sine theta, 3 sine theta, minus 3 sine squared times sine cubed theta minus sine cubed theta on the end here. We can tidy up, collect up these two terms, so equals 3 sine theta minus 4 sine 3 theta. That's it. So we've got sine 3 theta now in terms of just sine thetas. So that's it. Two lovely formulas for triple angles. Done.